it's going.
G'day everyone, how are you going? Back here in semester 2 for my course here. The first topic that we're hitting is our index laws. Now you might have done these in year 10, hopefully you have, and hopefully you've got an idea about them. I'm going to kind of run you through all the index laws, or all the ones that you might need. We'll do a bit of early work here. I'll run through these ones and kind of do some examples here each time, rub it off, go for the next one. So follow through as I go. Back at the indexes, let's just think about indexes. So what are we talking about? We're really talking about raising a number to a power. We call this the index or the exponent, and we call this number here the base. So that's what we're talking about. We're really talking about our squareds, cubes, power of 4, all that sort of thing. Collectively, we're talking about indices. Here's an example of an indice, base of 2 raised to the power of 4. Often we just say 2 to the power of 4. What does that really mean? It means that I'm taking 2 and multiplying by itself 4 times. And then I just do this simple multiplication, I come through with 16. So this is our index form. This is my expanded form, or the value of that index. Should be okay here. We should have seen that in year 10 somewhere. So let's now talk about our index laws. What are we using these for? This is when we're given some calculation to do and we want to tidy it up. Let's look at the first one through an example. What are we doing? We're multiplying indices together. So example 1 here, let's go with it. Let's say we go 2 to the power of 3 multiplied by 2 to the power of 2. A couple of ways you could do that. Let me do it the simple way, or the non-index way. I could go, 2 cubed is 2 times 2 times 2, that's 8. Right, I've got 8 there. And 2 squared is 2 times 2, 4. I've got 4 there. Oh, there we go, there's my answer, 32. Absolutely fine to do it that way, no problems at all, but we've got a better way. If we use this index law, then what that's telling me is that if I multiply indices of the same base, notice how it's the same base here, then I add the powers. So this would be equal to 2 to the 3 plus 2, or equal to 2 to the 5. And when you think about it, 2, 4, 8, 16, 32, same answer, isn't it? Okay. But if you get a question around this sort of thing, they want to see the use of the index laws. So this is correct numerically, but if it says simplify the following indice, we really want this answer here. Okay? So the rule is multiplying indices of the same base, we're going to add the powers. Multiplying indices of the same base, we're going to add the powers. Now I'm going to cheat a little bit. I'm going to use this example to do the second one. So let's just update. Example number 2 here. Let's update. Divide. So based on here, wouldn't I subtract? And wouldn't that then end up being 2 to the power of 1, or just 2? Let's tidy up here. What are we really doing? Well, this is still this. This is still this. 8 divided by 4, that's going to get me 2, isn't it? So you can see I've just used the same example but updated for divide and minus, and I come through to here. Now this here, if it asks you to write the answer as an indice, you probably really should write 2 to the power of 1. This is the expanded version of it. It's the same thing, I know. But if it asks for an indice, this is as an index, this is really the expanded number. Minor point, I'd never worry about knocking a mark off for it, but if it does ask, giving your answer as an indice, 2 to the power of 1 is probably better. Hopefully that one makes sense. Let's talk about the next one. The next one is one that oftentimes people struggle with, and I'm going to kind of do these two together. Okay, I'll do these two together. Think about this. If I have, I'm going to put n here, and I'm going to put a to the n there. Okay, so a bit like x and y. I'm kind of plotting something out here. And what I'm going to be doing is my example 3 is really working out a to the power of n. That's what I'm really working out. So let's put some n values along here. Now I'm actually going to start with 0 here. You'll find out why in a minute. 0 here, 1, 2, 3, 4. And I'm going to let a equal 2. So I'm working with my 2 to the power of 1s, okay? So I'm going to put 2 in there. That means I'll put 2 in here. So you would then see that 2 to the power of n, that means 2 to the power of 0. I'll leave that because that's kind of the one that I want to work out here. 2 to the power of 1 is just 2. 2 squared is 2 times 2, 4. 2 cubed, 8. 2 to the 4, 16. Now anyone who's done any sort of function work can realise, well hang on, there's maybe a pattern that I can pick going on here. Well, the pattern really is that every time I move up here, I'm multiplying by 2. And that makes sense because that's the base that I'm working with. I'm putting another 2, I'm adding another 2 on the end, aren't I? Now, we could work it this way and that's fine, but I want to actually work the other way. I want to work this way. So if I'm multiplying by 2 going that way, I'm going to be dividing by 2 coming the other way, aren't I? I'm kind of taking off 1 each time. Okay. Now where that allows me to work is, let's just do the next step. So wouldn't this be divide by 2? I'm just following the same pattern, aren't I? So therefore, 2 divided by 2 would be 1, wouldn't it? And that's this one here. Because this is a power raised to 0 equals 1. Now keep working with me with this next one. If I keep coming back this way, minus 1, minus 2, minus 3. Follow the pattern, dividing by 2. If I divide by 2 here, don't I get a half? And dividing a half by 2, I'll get a quarter. And dividing a quarter by 2, I get an eighth. So I'm still doing the same thing. I'm just dividing by 2 as I'm coming back this way. Now you might go, yeah, okay, great. So what? Let's re-express these in a different format for me. Okay? So couldn't I write this one as 1 over 2 to the power of 1? Haven't really changed anything, I know. Let's do the next one. Couldn't this be 1 over 2 squared? And couldn't this be 1 over 2 cubed? Right. Now the rule that I'm working towards here is this one here. Because if I have 1 over something, let's work out the decimal equivalent here. Isn't this 0.5? Isn't this 0.25? Isn't this 0.125? So what I'm recognising is, following the pattern coming back this way, I can get these fractions. And then if I take one out, let me just take this one. Let's just take this out. What I'm finding here is 2 to the power of negative 2, I'm just reading that from here, is equal to 1/4 or equal to 1 over 2 squared. So can you see how from here and here, something raised to a negative power is equal to 1 over that thing raised to a positive power. Replace the 2 here and the 2 here with n. 2 to the minus n equals 1 over 2 to the n. Write then in a more generalist way, a to the negative n equals 1 over a to the n. So if I have a negative power, I can take that whole thing, put it on the bottom line, make it positive. And why? Because I'm doing the same thing here. You can see the numbers coming through. And it doesn't matter which one I choose to do this with, it'll work every time. So my rule here is that anything raised to a negative power is equal to 1 over that thing raised to that same number, but as a positive power. Okay? So those two there, how do we figure those out? We figure them out based on this idea here of where we fit across this number line. Hopefully that makes sense. If it doesn't for some reason, just go with this idea. It does work. Believe me, it does work. If it doesn't make full sense to you, it's not really going to stop your thinking or your knowledge in questions that we do. Next one here. What we've got now is a fractional power. A fractional power. And all we've got to recognise is that the number down here is giving us what we are actually trying to do with it. So if this was a 2, we're working out the square root of a. If this was a 3, we're working out the cubed root of a. Okay, so let's just do an example here. what do we go up to? Example 4, I think. 1 over, let's go 16 to the half. 16 to the half. So what that's telling me that I really want the square root of 16. Now we don't normally write the 2 there because if there's nothing written there, we assume it's the square root. Just putting it there for clarity at the moment. Square root of 16 would be 4. So if you jumped on your calculator, went 16 to the power of half, you're going to get 4 coming out of it. Now if we did something that was going to be the cubed root, let's go 27 to the 1/3. That's going to be the cubed root of 27. And I chose that number logically because 3 times 3 times 3 is 27. So the cubed root of 27 is going to be 3. Okay. Now let's think about this. If I do 3 cubed multiplied by 3 to the 1/3. Alright, think about this. If I go 3 cubed multiplied by 3 to the 1/3, what's that going to equal?
1.
1. Good. Now 3 to the power of 3, what's that? 27. Right? What is 3 to the 1/3? Well, actually let's go a different way. Let's look at this. Take that and bring it back to this idea here. This idea here. Okay? If I'm multiplying, I add the powers, don't I? No, I've screwed up. Don't worry. Ignore that bit. I didn't know where I was going there. Stick with this. Alright, well, let's move on. I don't know where I was going on that one. I had something in my mind. Alright, let's do this one. A to the m raised to the power of n. Let's think about this as an example. Example 5. Let's go 2 to the power of 2 cubed. 2 to the power of 2 cubed. Now I want you to forget about what's in there. Right? Let's imagine what was in there was just another letter. B, C, D, whatever. Right? What would be b cubed? What would that mean? That would mean b times b times b, wouldn't it? Right? Just like over here, 2 to the power of 4, it was this number 4 times over. So if this was just b cubed, then you would write b times b, wouldn't you? Right, okay. But if this was 2 squared, it was an indice by itself, wouldn't that mean it would be 2 squared times 2 squared times 2 squared? Can you see how I'm just doing the same thing? I'm taking the outside thing first, the cubed part, and saying, well, that cube means take the thing in here, multiply by itself 3 times. And I end up with this. Now, can you see how I can use this first index law? Because I'm multiplying with the same base. So that would mean that I just add the powers. This would be equal to 2 to the 6. Now we can work that out, 2, 4, 8, 16, 32, 64 if we want. But here's the trick. Instead of doing all this, these two multiplied together, they get us that 6, don't they? So we can see this and we can understand what we're doing, but we recognise that really we're just multiplying the 2 and the 3 together. And that's how we get there. And hence, when we've got a power to a power, we multiply the indices. Power to a power, multiply the indices. Okay? Alright, example number 6 up here. Here we are. Right, let's look at this. So let's do an example here for example number 6. AB to the n. Okay? I'm going to use my example and say 6 squared. Now 6 squared, 6 times 6, 36, isn't it? Everyone agrees with that? Okay? So we know the answer to this is going to be 36. Now to show that this one works, I'm going to write this as 3 by 2 squared. Because 3 by 2 is 6, isn't it? So I haven't changed anything, I've just written 6 in a different way. 3 by 2. Now using this law, that would mean this is equal to 3 squared times 2 squared. 3 squared is 9, 2 squared is 4, multiply the two together, I'm going to be here, aren't I? So I can show that this one works, because if I just work 6 squared, I get 36. If I split it up into 2 times 3 and then use the index law, it also works. So here's another way to kind of rearrange some things that can sometimes make it easier for you. Last one, this one, it's very similar to this. Let's use a similar sort of idea here in working it out, all right? So let's do a fraction. Let's do 2 divided by 5. There's my fraction. And I'm going to go 2 divided by 5 squared. Now, 2 divided by 5, let's work that. That's 0.4, isn't it? 0.4, you'd agree? 0.4 squared, 4 times 4 is 16, 0.16. So if you just put that on your calculator, you will get an answer of 0.16 out. Think, 2 over 5 is 0.4. 0.4 squared, 4 fours are 16, move 2 decimal places back in. Let me show you how to do that quickly. Okay, 2 over 5, maybe I'm moving too quick, is 0.4, isn't it? How did I do that? Well, isn't this equal to 4 over 10? 4 over 10. Now, how to get to here? I'm dividing by 10. That says pick the decimal place up, move it 1 spot to the left. 0.4. That's our decimal system. Multiply, divide by 10, move the decimal place. So I can get my 0.4. Now what I've done here is I realise I've got to square that, because that's what the question was. So I can square 0.4 in my head, but this is how you do it. Move the decimal point back out over here. Make it into 4. And you're thinking, you can't just change it. I'm going to change it back. Right, so I'm now at 4 squared, but I recognise that I've got a decimal point that I'm hanging over there, right? Because I moved it 1 spot. Now I've got to be careful that this is 4 squared, which came from here. So it was that, but I moved the decimal place, so I really moved it 1 spot here and 1 spot there, didn't I? So I've really moved 2 decimal places. I've moved 2 to the right, because that then gives me 4 by 4. 4 by 4 is easy, that's 16. But because I moved 2 decimal places, I've got to move 2 back in. Now that's the thinking that goes on in my head, crazy place, but that's the thinking, is that I can make this easier by moving the decimal place out the way, then I can square it, then I can move the decimal place back in. Okay? And you can do this for any number you like. You do this in your head and then you realise, oh yes, 0.16. Now I just look at 0.4 and say, well, I'm going to square it, it's going to be 0.16 because 4 times 4 is 16. And I know my answer has to be less than 0.4. I can't multiply something by 0.4 and actually get a bigger answer. Anyway, enough there. Right, so we're at 0.16. 0.16, 2 over 5. So I know the answer is going to be 0.16, but let's bring the power inside. Let's bring the power inside. So 2 in there, 2 in there. So what do I end up with? I end up with 2 squared over 5 squared, don't I? 2 squared over 5 squared. Well, 2 squared is 4. 5 squared is 25. Now we've got to show that this is going to be the same. Isn't this going to be the same as 16 over 100? Multiply top and bottom by 4. Now, dividing by 100, similar to what I did here, but now I'm going to move 2 spaces, aren't I? Which will get me the 0.16. So this is showing you that this idea works. Okay? I worked it out manually myself, worked it out using the index law, came to the same. Now with a lot of this, initially it's going to seem like there's 14 different things to remember. Very quickly you get good with it, but you've got to spend the time to practice. With our Year 12 course, just at the moment, I spent about 3 minutes doing this with my Year 12s, and then I jumped into what are called logarithms, which are a completely different thing. It's kind of another way of expressing these. And if this part of it's not good, then the logarithms is going to be hard. But honestly, once you get good at these, they're really quite easy. Spend the time getting good at them, because that will make it a lot easier for you. Hope this video helped you. Thanks very much.